Great. Okay, so let me get started. Okay. Hi, everyone. My name is Juno Choi. I'm the Associate Dean for Research and Creative Work in the School of Architecture at USC. I'm also working as Associate Professor of Building Science in the School of Architecture. So actually, this seminar, as you know, it is held bi-weekly, and actually, as compared to the previous one, we changed the schedule from Wednesday to Monday because of some internal school schedule conflict. So I hope this is schedule, I hope it works well. And today we will have some two speakers. So David Swartz and Peter Bacevice will talk about the Project Heroes. So actually Project Heroes has been done based on the collaboration between the HLW and USC School of Architecture and the USC Keck Medicine. So yeah, so let me introduce our presenters. The Mr. David Swartz, the FAIA, the FAIA, has been working for HLW since 1995 and has been a lead technical partner since 2000. So he has worked on a variety of projects that have been published and won number of awards. So that Mr. Swartz is a CA-based senior partner at HLW, and also he has received some AIA, the Young Architect Award winner in 1998. And he has devoted his career to the pursuit of technical excellence and the challenging architect to understand the technology of buildings they create. So he's a member of USC Board of Governors and also board member of USC Architecture Guild. He studied at the USC Architecture for his master's degree of architecture. Our second presenter, so Dr. Peter Bacevice. So he is the director of research for a global architecture practices, as well as an academic researcher whose work planned to plan the boundaries of organizational theory, education, and design. So he received a PhD degree in education and organizational studies at the University of Michigan in Ann Arbor. So yeah, as I mentioned, the Project Hero has been conducted based on the collaboration between HLW and USC. In the School of Architecture, many student members have been participated in the project, and the David Swartz team is ready to start for phase 2, still based on the collaboration with the USC. So yeah, please join me to welcome the David Swartz and Peter Bacevice.
Thank you.
Okay, so let me close my window and then, yeah, please share your screen. Maybe.
Doing that now.
Great.
Can everybody see the screen?
Yes, yes.
Okay, that sounds great. So one of the things I wanted to do is really thank Junho and the School of Architecture for this prestigious invitation, really allowing us to talk about Project Hero, which we already mentioned was a study and conceptual design proposal we did in collaboration with the School of Architecture and School of Medicine. We also had over 35 national and local consultants working on it. And the project lasted only 7 weeks. So you're going to see a tremendous amount of work done in 7 weeks. And we actually had as many as 60 people with their hands on this project throughout the process. So one of the things I could show you sort of, here's an image of the hospital portion of the project. I'm showing you a little bit as a teaser, and it's something we'll discuss a little bit later and show you a little bit more. But I think really one of the most important things to really understand is why I wanted to do this project and what I hope the results would be. Really to first kind of put you into my mindset. or at least our mindset. So one of the things I'm showing you up here is all of the studies that were done by my company HLW in a variety of different firms on our current COVID crisis, and saw that really all our responses placed us in a defensive position to a pandemic that's already here. You know, our studies really, the studies we did were valid, they're worthwhile, but we really sort of asked the question, what if we're able to stop the virus at its source and create a solution that did not place us in a position as victims, but in a position really to control our future and to really have an impact in saving our way of life? You know, wouldn't that be a direction we'd want to seek or really study? So in some ways, we felt as though our current crisis, that we can really only mitigate our current issues and we really can't solve them. So one of the comparisons I like to make is, a while back I gave this analogy of our current crisis, comparing it to giving bulletproof vests to everyone in a scenario where we really only allow our citizens, to carry guns unhindered, you know, instead of looking at the stem cause of the problem that really endangers us. I also didn't really like the phrase new normal, and really felt that our cities and our existence is not based on social distancing. Let's take a look at New York. Are we going to say that our stadiums, our subways, our theaters, and even New York City itself is no longer valid in this new normal world? Are we going to spread out to suburbia and really choke off the last green spaces we have? So what effect is this really going to have in our world? So here comes Project Hero, this interdisciplinary study with the USC School of Architecture and the Keck School of Medicine that fundamentally asks the question, is there a built solution that can be implemented to stem future outbreaks and stop a pandemic? What can we do, really asking ourselves the question, what can we do as architects or designers to create an environment where this problem really can be solved? You know, consider the trillions already spent. You're seeing $1.9 trillion here. And the loss of life we've already seen now, arriving close to 200,000 in the United States right now. And we can ask this question, is an ambitious project that we're proposing, and we'll show you, really doable? You know, considering the loss of life currently exceeds, just the loss of life in the US just currently exceeds Vietnam, Iraq, and the Korean Wars combined, we can really sort of ask ourselves a question, is this multi-billion-dollar proposal, our peace of mind and the fact that we could really feel safe, or that we even have a program or response to protect our future, really worth it? And yes, this is also sort of what Project Hero's about. So really, before I run through the slides, I think it's important to mention the team involved in this 7-week study. It's important to note that one of my philosophies is that not a single individual can produce the work. I sort of have this belief, I don't have a belief that a signature architect is a person that's all powerful and can really produce a project on their own. And it's just important to note that. When I asked Keith Teo, who was one of the students on our team, who really designed this question, he gave a very interesting answer. He really felt it was the team who designed this project, and it was really a team effort with everybody working together. And that's the ideal response we want to see. So here you can see the HLW and USC team and the Keck team that was involved. We also had 4 Keck students involved, a pretty substantial HLW team that a lot of the people over here were on and off the project. We have administrative help from the School of Architecture, as well as June Ho and the deans of both schools were involved in the project. And here's the student team itself, in which we raised about $55,000 to pay for 6 of the full-time best and brightest students we felt who helped us work on this project. They did a tremendous effort. These students were working, I think, 60 plus hours a week for that 7 weeks. And we had over 70 applicants on this project too. And as you can see, we had Andrew Bloom, who was our student leader, Keith Teo, and we had Bobby Lee, and Bobby's actually at Columbia Graduate School now. Sushus He, whose name is Snow, is involved in a project. Mitchell Fu and Yuchi Tian, who's also now at Columbia University. And this, we also had, I think it's important to know that this was our industry involvement. We had some of the largest contractors in the United States involved. Even Warner Brothers and Paramount contributed to the project. And there was a really great team of people that invested in this project to make it go forward. And we've also had some publications on the project. We've been fortunate. We had a large article in Architect Magazine, one that I wrote, and then one that was written on the whole project. Archinect, the Architect newspaper, and USC Architecture wrote about it too. So I think before I get in solution, what we proposed, I really want to introduce Peter Bacevice and talk a little bit about the research he did on the project. Peter is a Ph.D. He's our Director of Research here at HLW, and really was extensively involved in Project Hero as the research leader. So, Peter, here it is. Take it away.
Thank you, David. So in these next few minutes, I just want to walk through a little bit of the background research that we did, which was really meant to be a series of thought starters early on in the project to help frame this for the team. So we've shared versions of this early on. It was very helpful to frame the conversations about what we wanted to do and the bigger context of this. So obviously what you're seeing here, we all know the story of the coronavirus and how those numbers unfortunately have been increasing around the world. You go to the next slide. We also took a look at the fact that this project is really about it's about fighting a pandemic, but it's also about supporting healthcare infrastructure around the world. And just a couple of different statistics that you're seeing here that we pulled from the World Health Organization. Generally we know that there are significant portions of the world that are medically underserved. Everything from inadequate water and clean water and access to simple things like being able to wash hands or inadequate waste management. In a country like the United States where the public health message is about things like washing your hands in order to halt the spread of germs, we know that in parts of the world that's not even possible. If you next slide, please. Looking at our own country, we know that again, there's a lot of medically underserved areas. And this image that we showed the students from the New York Times, this map of the country shows the shaded areas represent places where an emergency room is more than 30 minutes away. And if you stop and think about that for a minute, what we know about COVID is that this is a virus that affects the respiratory system. There are a lot of people in this country that have pre-existing conditions. They need quick access to health care in a crisis like this. And if you look at half the country's geography is more than 30 minutes away from an emergency room, let alone not having any other facilities for chronic care or other just basic types of medicine. That we saw Project Hero as an opportunity to again rethink how you deliver healthcare and healthcare facilities around the country. You go to the next slide. A couple of challenges that we put out to the team throughout this phase. We thought about this, and we know that this was not the first mobile healthcare system to be designed. The image you're seeing there on the right was an image I found. It's actually an old civil defense shelter. But this country in the past has invested billions of dollars in infrastructure to sort of fight against whatever the crisis is at the moment. And we have this legacy of aging civil defense architecture. Even more recently, when there was when Hurricane Katrina hit the Gulf Coast back 15 years ago, there was investment in mobile healthcare facilities, and quickly those projects lost funding. And one of the quotes that we found when we were doing our literature review was that these skills and this knowledge is very perishable. That, you know, you can invest a lot of time and energy to create these systems, and then if they don't get used, they people forget that they exist, or they forget how to use them. The other thing was that, you know, we know that there's also needs to mobilize quickly, and as David indicated, you know, this project took 7 weeks. Well, one of the things that we, you know, that in reading a really great article about how the Army Corps of Engineers procured resources in this current pandemic, you know, a lot of things are about getting stuff done that might not be perfect, but just simply brings a solution forward quickly. And so, you know, we're trying to balance a number of different objectives. Designing something quickly that's effective, but also something that will have long-lasting impact. Go to the next slide. So what you'll see on these next few slides are some of the other thought starters that we put together about mobile hospitals. As I said, this is not the first mobile hospital typology. We have land, sea, and air-based versions of it. Go to the next slide. Typically, you know, with land-based mobile hospitals, we've seen, especially in the current crisis, a couple different configurations. We saw tent hospitals in places like Central Park. We saw areas where you can bring in vehicles and set up trailers along with tents on the ground. And then places on the right is actually the Javits Center in Manhattan. Other big cities use their convention centers, and this is where the Army Corps of Engineers brought in equipment to convert existing facilities into healthcare. Go to the next slide. There were a number of different design criteria that, in reading about mobile hospitals, that we told the design team about, and just, again, these are things to consider. Design intent, you know, there's a lot of different types of healthcare facilities, everything from, you know, there's different needs if you're designing facilities for chronic care, people that have chronic conditions like asthma, versus things like acute care where you're dealing with emergency medicine or trauma. You know, the idea of needing to isolate different units and isolate biohazards. So if you're designing a fully self-contained system, you know, how do you do that? And then that led us to the various MEP considerations, and this is why we had a large network of MEP consultants. And then programmatically, one of the things we learned, and go to the next slide, this is just a point about adjacency. This is from some work that we found, but one of the interesting findings differences between European and American emergency departments is that in the European model, there's this idea that you have communications at the core, because everything is happening very fast, a lot of information, a lot of uncertainty is happening, and so a lot of information needs to be coordinated. And another thing that we learned talking to a gentleman who's in Europe, medical education expert, is that you want to also think about a facility like this as a way to educate people so that, you know, they can learn from what's happening on the ground, and they can review cases, because again, you're trying to make sense of a virus in real time. So how do you even think of this as an education facility? At the same time, wanting it to be something that anyone who's a medical professional could walk into and be able to use on day one without a lot of training. So then that led us to the next slide, just thinking about the hospital organization and what types of people work in it and how they're organized in space. You go to the next slide. A few other things we wanted to consider. You know, one, we know that we're dealing with a lot of tragedy. And this image here is from New York City early on in the crisis, when the death rate was actually very high and the hospital morgues were being overwhelmed. And that led to these mobile trailers that were being set up all around the city. You know, when you see this in the city, it's a visible reminder of the tragedy and the human toll. So in thinking about how that even influences the design was something that we wanted to bring forward. So if you go to the next slide, you know, that brought us to, so how do you design for, how do you use design to improve wellness, well-being, patient healing? And it's not just about the patients, it's about their families, it's about the entire community. So this kind of thinking I think really influence the design. If you go to the next slide, we've thought about things like data and how data gets transmitted throughout a hospital facility, especially nowadays with a lot of medicine and a lot of less critical medical visits being handled remotely. There's a lot of sort of virtual and digital touch points. So even thinking of the system in terms of information technology was something that we wanted to give some thought to. So the next slide just simply shows some of the references that we accumulated. We don't have to, we can move on from that, but we have a running list of things. And then in terms of case studies, we wanted, one of the points I think that's worth making here is that as much as this is a design innovation, I would also argue that this is a process innovation. And by that I mean that, mobile healthcare facilities, there are ways that you can improve upon the design, but what you'll see in the later part of the presentation, a lot of this is how you organize knowledge and skills to design a complex architectural system, and then how you move it around, how you distribute it around the world where it's needed, I think is really, I think another part of the innovation of this project. So a few examples that we just shared where shipping containers or things that are based on shipping container architecture were used. So in places like Haiti, where there's just not a lot of access to health care, and this goes back to my earlier point about healthcare gaps around the world, there's simple, effective ways that you can use this type of architecture to create mobile or community clinics in rural areas. You go to the next slide. There are many examples that we share, but this is just one where shipping container architecture can actually be made really very functional and can become a very almost beautiful permanent part of a community. And this is one in Indonesia where it's a mixed-use primary care facility, dental clinic, but also library and civic center. Next slide. Closer. We began to see some other innovations that were specifically triggered by COVID-19. In this example from Italy, we learned about some architects that had designed mobile ICU. These were specifically designed to be erected in facilities like the Javits Center or a large convention center, so not exactly a self-contained hospital, but something that could extend capacity in other areas. Next slide, something closer to home. This was a similar idea. This you probably are familiar with the portable on-demand storage units or pods. You see them a lot in driveways of people's homes. Well, they were also able to convert their shipping or their architecture into emergency rooms or ICU units, and they had a contract with the Army Corps of Engineers. Again, similar to the previous example, these are facilities that you would bring into a large convention center. They're not necessarily freestanding hospitals. And then the last example I'll share before we turn it back over to David was another model from Grimshaw where they did something that was a testing center. Again, a rapid deployment, rapid design, but again, very limited in terms of its use and in terms of its applicability. So as I turn it back over to David, think about some of these things these points that I made about process innovation, design innovation, and the totality of the solution.
So what I'm going to do right now is to present the overall project first and then double back on how the project actually works or is implemented or envisioned. This just makes it really much easier to understand the process after seeing the results. So right now we're showing this image, this urban image of Rio de Janeiro that we're using as one of our examples. And there are 6 building types for this project that really make up Hero. You're seeing 5 here. I'll explain the 6th a little bit later. And they include really the hospital. You can see the patient rooms. These are all individual buildings. Staff housing as an individual building, support, which actually support typically deals also with decontamination, and wellness, which deals with food, administration, fitness, and conferencing. So, and then we have the triage building, which you're not seeing here, which is a smaller building type that we'll talk about a little bit later. So what we're doing really is bringing a small city to the next ground zero location of a potential virus threat that could really turn into a pandemic. So here you're seeing, this is the hospital thing that you just saw a little bit while ago. And what I wanted to just talk to you a little bit is about the modules themselves. So for this project, we are using the shipping container module size, the 8 by 20 feet or the 8 by 40 feet and 9'6" high. Our project doesn't readapt a shipping container, rather we create an entirely new intelligent module. We look at this really being manufactured by the automobile industry because we want a level of intelligence associated with the module from self-diagnosis to the ability to really quickly connect the units together. So if connecting piping or conduit, it has to be able to almost snap into place. The project was designed based on solving technical constraints first, because there's a tremendous amount of technical issues as a result. And then our design, you were looking at the curves, you're looking at the colors, the graphics was really there to soften the architecture, both in an interiors and exteriors. Some of the things Peter was talking about, the materiality. Like I said, one of our goals was to be able to attract worldwide talent to be part of Project Hero when implemented, and to be really the best response in stemming a future pandemic by going directly to that next ground zero location and literally being set up in a week. That was our thought. It's like bringing the best firefighters and the best equipment in the world to fight a fire. So here you can see some of the program elements that make up the hospital portion. I'm not going to go through it in detail, but we do even have a surgery suite, an x-ray, and a lot of the components that make up a hospital. Here you can see an interior portion, the elevator lobby. And if you can notice here, and you see this, basically since these components are going together, you can always see where they go together in all of these renderings. And you notice this is actually two pods going together. And our concept is when you take it apart, there's actually shutters that go down for shipment. So when these things ship, the windows aren't exposed, everything's closed up. And then when it goes together, the shutters all go up and it becomes a usable unit. And here you can see the operating room. You can see these are made up of 3 pods actually. And this is the nurse station. You can see behind the glass here. You can see also the division of the 2 pods themselves. Patient rooms, this is another complete building assembly right here. You can see we have the connector portions connecting to the hospital. So the patient rooms in the hospital are all connected together for obvious reasons, for decontamination, and also if we have to wheel someone from patient room to the operating room, they can do that without having to go outside. Realize each one of these buildings is fully independent, both mechanically, electrically, and plumbing. I'll show you that a little bit later. Here's some of the components that make up the patient rooms themselves. And this is a small plan. It's kind of interesting to note in the plan, and almost all the buildings are quite similar, where we have a 20-foot module all together. We typically always have a corridor between. We kind of have the stairs at the end in almost all cases, and the corridor units can be almost 40 feet wide. And that's where we bring a lot of our utilities down through the base portion of the project. Here you can see the interior of the patient corridor. You can see what a patient room might look like. This is actually a module and a half. The patient toilet rooms are behind that. So you have a patient room, a toilet room, and a patient room. Together, that's 3 modules. This is staff housing. We have these fold-up balconies that are pretty cool. And these then, in transportation, the balcony would fold up and the shutters would go down. So we're actually housing staff on site here. So we're actually making really a city to be able to handle the pandemic. You can see a very similar sort of plan here. We have different housing types. We have housing for doctors, which is a single occupancy. We actually have bunk beds also to be able to house double. We have these really nice pantries that can be used where envision people could come back from working all day and have some food here that's also available, as well as going to the wellness center. Here's what a unit looks like. It's relatively small. The bed also folds up and forms a desk, you can see. And then there's the support facility for decontamination, IT, storage. And here's this unit back here is kind of interesting to look at. This actually is the unit that makes the buildings all function. We have the emergency generator, There's a black water tank. You have the pumps and water heaters and things located in here, and then fresh water tank above. So it can really function on its own. Here's some of the pieces that make that up. You can see decontamination, storage, and then the wellness center itself, which is what I was talking to you about, where you get food support really for the staff themselves. These are all the pieces that make up that wellness center. We even have a vegetable garden on the roof, make it a little bit more interesting. Laundry facilities for staff. This is what a kitchen would look like potentially. This is the dining area. So the concept is we really want to attract talent to this facility. In order to make it work, we have to, in many ways, saying we're bringing the best talent in the world to fight a virus. So in order to bring the best talent, it has to be a nice place to work. In many ways, I always say it's like a cruise ship. The spaces are small, but they're nice. And the people that are working there are really well taken care of. So as well as the patients themselves. So if I'm coming into a city or a hospital saying, hey, I can perform this same function, we're saying, well, we have people who are the best trained in the world to specifically handle this problem. Here's a recreation room, there's outdoor vegetable garden, outdoor area. And this is the triage center. So the triage is a small building that's located throughout the city. So if I'm going into a city like Wuhan, for example, the first thing I'd do would be setting up a lot of these triage centers throughout the entire city where people could go to, walk in and be evaluated to see if they're going to go to the hospital portion of our facility. Here's what the interior of the triage might look like. And so now I'm going to actually, now that I showed you the results, I want to show you how this actually all works. Because if I explained how it worked first, you wouldn't really understand it without sort of seeing the results first. So one of the things we decided to do is from the inception, really Project Hero was intended to have a global scope. It would have this concept of these specific modules that they would be stored and distributed on demand as a kit of parts. You know, in a novel disease, we know outbreak could start anywhere, so its effectiveness really lies in its rapid deployability to any location. To make this possible, we identified several sites for distribution centers around the world that you can see. So we sort of made these circles, and I think there's 17 total. And from that specific center location, within 2 to 3 days, either a vehicle or a train could get to a specific location pretty much anywhere in the world. That was the concept. We also have a series of container ships. If you see these items like this, like A, B, and C items, that represents container ships that have modules that are preloaded and ready for implementation that could go anywhere in the world, especially in specific areas like Indonesia, which is made up of a series of islands. So in transportation, typically our primary transportation we thought was by flatbed truck or rail service secondarily, and lastly by ship, because shipping actually is a much slower process. And we really looked at the shipping process as really a supplement to, if we were to implement, say, in Los Angeles, Detroit is our major location, would come in through Detroit, potentially through Vancouver, and we have a shipping stop, I think, in Puerto Vallarta that can come up the coast and augment the Los Angeles location as this thing gets larger and larger, or even smaller and smaller. So also the thing that makes this work is the concept code, a global network and training and distribution center. So we have 2 of these specific locations throughout the world here, one in Detroit and one in Chongqing, China. And what this is a place where we store a lot of the modules. We have like 1.5 million to 2 million square foot warehouse that stores the module, but it's also a place where we train staff to build the modules. So you have construction crews come in that are pre-trained to know how to build these things really quickly. And you also have staff from the hospitals or nurses or people that run the facility that come into a mock hospital and actually learn how to use the facility in the correct way. We also have these just global training and distribution centers that really are a large warehouse where the modules are stored and distributed. Both of them have office functions that work with it too. I think the thing to understand about the distribution center, like if your distribution center this one's in Brasilia, in Brazil, we would expect that Brasilia location to really understand the environment that they're in and understand that they're implementing to a city within that zone that they know how to implement. that they've done their homework up front to understand how it actually would work. So here's some typical deployment strategy. So we're showing you a city deployment. So the thing that's interesting about Project HÉROE is we're implementing in the city streets. We're not building foundations or footings. We have these bases that we've designed that I'll show you a little bit later that actually go in the city streets themselves. So this is showing you the location in Brasilia, just a small portion of the implementation. And then this is showing you the triage portion, which is actually scattered throughout the city that you can see here. So here's that one hospital location we're talking about, and here's a whole series of triage locations throughout the city. And then that hospital portion would grow maybe into 3 sections. We do something similar for suburban and rural. For suburban, we realize that we might have parking lots available like at a mall. And for rural, we have just small streets that maybe we actually have reduced the size of some of these elements. And with the rural implementation, we're typically looking for the closest larger town that we could where we could implement the hospital. So the rural would have the triage centers located and would be bringing in for those. For program, it's kind of interesting. So for program, it really all comes down to bringing a large program. We're proposing about 2.2 million square feet to this location, bringing, like I said, the best people, the best equipment, and the best contract tracing in the world to stem the virus at its source before it becomes the next pandemic or our next new normal. And studies have really shown that every week makes a difference in stemming an outbreak and bringing a solution quickly to the source to stem the next outbreak. I think what's interesting about this specific program development is this is really just showing over here just one hospital block being implemented. So to be 1,000 patient capacity, which is what we really wanted to create, we need about 2.1 million square feet. And that's about 13,348 modules. But what's really interesting, with 7 housing blocks, we have 42. I mean, with 7 hospital blocks, we actually have 42 housing blocks. So there's almost a 6-to-1 ratio. For 1,000 patients, we really have to have 6,000 staff servicing them. And I think you can see that here in that percentages. And the reason, one of the reasons we didn't want to use hotels or we didn't want to use some of the structure of the city to house our staff is for the decontamination. We want to control the whole process. So for the technical aspects of this project, this is what I was talking about before, where we have our transformer vault for electricity, black water tank, pumps and water, pump hot water tanks, and then we have the fresh water tank. And this specifically is really able to function for each individual building. So if I'm erecting one building, I can be assured that that one building can survive on its own. So as this thing gets bigger, we don't have that worry. As it gets smaller, we also don't have that worry. And this is the base pedestal system we were talking about. If you actually stack 4 of these high, you sort of get 9'6", which is a full module. So when it's being shipped, you can put 4 of them on top of each other and ship that module by itself. So these are actually hydraulic jacks that are located, and these hydraulic jacks are sort of all connected with conduits so that there's an ability to raise these on site and level it in place. Because as we know, city streets aren't level, right? There could be a slope in many different directions. So the concept is we set all these platforms out in a level platform, and then we sort of start stacking everything up and create the buildings themselves. Our goal is we felt a building could potentially be built in 6 hours, really by stacking them up, as long as we have a quick connect system and the things can go together really quickly and precisely. Another concept we came up was the elevators. So the elevators are already pre-built. And since the maximum module size is 40 feet, our buildings are 4 stories. And that's specifically how that works. So when you actually raise this elevator in place, it actually is a fully functioning elevator. And here's some of our stairs. And you can see the stairs actually has sort of a scissors component. So it can go from a 4-inch riser to a 7-inch riser based on the height and on the different conditions. And this is quickly showing you some of the technical diagrams, how the pieces and parts go together, anywhere from its structure to the mechanical system, to the electrical system themselves, to fire protection, which is a dry suppression system, and then everything combined. It's sort of looking like you're opening the hood of a car and you're seeing everything pushed together very tightly. Here's a section through it. You can see things are tight. And this is our distribution. Horizontal distributions typically at the bottom. Vertical distribution is typically in the 4 units above. A code diagram just quickly showing that we wanted to create 1 hour separation really between the modules. The shutters that we're using for transportation are also being used for fire separation so that these buildings can get close to other buildings in city streets. So we had to look at fire separation distances too relative to how we place these buildings. So I'm not going to get into too much detail with code, but just rest assured we did kind of look at this. So this is mobilization, implementation, and construction. And so with mobilization, we had certain things where we said, how do we mobilize Project HÉROE? How do we know it's supposed to go to a certain city? How do we know there's really a pandemic there? So we had this whole concept of different phases of detection where there'd be this worldwide network that could really look at future viruses. That's actually happening now. And then when we see a potential threat, we can say, is this a real threat or not a real threat? If it's a real threat, then we go into phase 2, and then they go to the site, specifically take a look at it, and really start the mobilization process, where you might bring in Project HÉROE in different phases, where you bring it in with the triage buildings coming in, and then we set up primarily the hospital and all the support functions, and then it can grow and grow from there. And here you can see sort of what it might look like in construction. And really to facilitate construction, the project studies really a variety of worldwide locations for implementations to ground zero. So we're expecting each distribution center will have a deployment strategy specific for a variety of different cities within their reach, whether it's suburban or rural or whatever. The locations will be predetermined to ensure the best possible outcome during construction. Some of the things we have to be aware of is when we're constructing, we have to bring these units in the correct sequence so that each unit can be built correctly. That's how we can get the speed. Here you can see that base unit going in too. That's what levels that platform itself. And it's really just a simply stacking them and connecting them. And the connection system that we came up with was sort of a quick connect system. Anyway, I'm trying to get rid of this, sorry. So now we talk about, once we're sort of done putting all of these together, we have this disassembly, site reclamation, and really next steps. And since we don't have too much time left, I'm just gonna try to push this through in the last couple of minutes. So for disassembly, it's kind of obvious that we're sort of when we have the hospital set up at its maximum size, it could be even up to a 3 or 4 or 5,000 patient hospital. It has that potential as we bring in more of those distribution centers. But as the virus starts to, contain itself and starts to get smaller and smaller, we can start to pull this away. And you can see these different steps where we have a larger setup. It gets smaller and smaller to eventually we really just have one hospital unit and all this support function specifically for that. Once we no longer need that, then it really goes down to zero. But we're also thinking, when we're done, what do we leave this city? We can't, if it really are saving in some ways, helping the world to not have its next pandemic, then what should we leave over? What should be left here? And I think one of the things we decided to do was kind of interesting, is where the first hospital was actually set up, we realized that we're actually bolting in, as you can see, here's our base platform. We're bolting in the base platforms with anchor bolts to secure the buildings to their site. And when we remove it, there's actually a series of holes. So our concept was we would actually screw in these medallions as a memorial to where Project HÉROE once was at its prime location. And even with these planter boxes that we actually used as bollards that surround the building, we could turn them sideways and make them into benches or use them as planters. And you can see the actual planter box can fit easily into a shipping container and leave parts of that as a remembrance of the project being there, similar to what you're seeing here. You can see the leftover footprint and some of the benches and things that were left over. So the remnant of the hospital or the building left behind to sort of pay tribute to the heroes, not only of the city, but to the heroes of the people that actually worked for Project HÉROE themselves. And I think one of the things to understand is the project really has potential for other crises as well. It could be a temporary hospital for like people affected by earthquakes or floods or fires, hurricanes, tornadoes, or even human conflict. The housing module could become transitional housing for homeless or refugees. Its rapid deployment and ability to accommodate many different types of programming allows it really to be versatile in its use. The strength of Project Hero lies in its holistic approach to pandemic preparedness. It begins with input from architects, doctors, nurses, engineers, logistic experts, hospitality professionals, and will continue to integrate diverse experiences into its design to constantly improve its success. You know, our final goal really was to ultimately see the project realized. That's what we're working on right now with our phase 2. And our project is looking really to have an impact in the world and to really invoke change. And this really is a tremendous opportunity for us to really make a difference and to propose a solution that will make a difference. So we really have this unparalleled opportunity as architects to save future lives and truly change the world. And putting architecture at the helm, I think, is really what's fascinating about this. And in my mind, could really anything be more exciting? So our project, lastly, our project's hope is to stem future worries and to bring the best resources to bear in the next crisis. You know, it's a real proactive answer as opposed to the defensive strategies we're seeing today. And that's it.
Great, great. Thank you very much. So let me open to the floor. So if we have any question, just ask your question directly to Peter or David. Any questions?
I probably have to open mine.
David, could you stop the sharing, the monitor, so that we can see each other?
Okay, just wait a second. Trying to get this thing opened up. Stop share. Okay, got it.
Okay, great. Okay, thank you. So, yeah, any of you has a question for David or Peter?
Quick question, yeah. Really interesting project.
Yeah.
Thanks for sharing. It seems that a big part of the project is sort of laying out this global network that can be used to sort of distribute and implement the modules in these different configurations. And I'm curious what constraints you considered in setting up that network, either economic or geographic or cultural.
Well, I mean, economically, I think we thought that considering the amount of money that's been spent on our current virus, not only by the United States alone, but by the world, that when we did an estimate of this project, yes, it's in the billions. You know, I did a preliminary estimate, I thought around 50 billion to implement worldwide. Doesn't seem to us like a lot of money considering the specific situation at hand. It could potentially save future lives and be used in so many different ways. We know there's definitely a lot of political problems, especially in today's world, getting the whole world together to do something like that. But one of our goals with the project and setting it up in China, realized if United States, China, and Russia in Europe get on board with this, the rest of the world could potentially fall into place. I think Russia's suffered tremendously. I think they would understand the need for this. I mean, when we've actually spoken to some Chinese investors on this project already, and they said, why would we be interested in a project like this? In China, we've handled this relatively easy. You know, we were able to stop the virus pretty quickly at its source by doing some of the things that we were doing. And my answer to them was, when you take a look at this project, it's a little bit different. I said, we're trying to bring the best people in the world to stem a virus. So we're trying to attract them with this architecture so that they're not going in tents. Could you imagine a doctor that makes $1 million a year wanting to go to a tent and risk his life to fight a virus, as opposed to going to Project Hero, where he knows the best people in the world are also going with him, we have much more potential. So that's how we would sell it to a country like that, showing them that we're trying to bring the best people, including Chinese doctors, to fight this virus. And I think with that in mind, it's like the analogy of the best firefighters with the best equipment in the world fighting a fire. That's the real concept.
Hey, great. Okay. Hey, David, I have a question actually. First, personally, I'm very glad to see all the research outcome have been conducted very successfully. And also, I believe that the many good research parameters have been well defined and investigated by our USC student research member and under your guidance. So I know that, as you mentioned, you have a plan to do phase 2 research. And then actually, can you tell us a bit more about some kind of a technical plan that you will do during the phase 2, and also how much time you are thinking to complete the whole project?
Well, phase 2 is actually, we've decided phase 2 really needs to be proof of concept. So we need to really build a portion of this project to show that the Quick Connect system can work, that the base can work, and that it can actually go together as quickly as we say. So we've reached out to a lot of different people for funding on this, and we've been fortunate there is a lot of interest. So with that, we think with getting all the agreements in place, and with doing a business study, which actually is being done right now, we're going to hopefully be able to launch into phase 2, where we can do the drawings and figure out all the different aspects of the project to make it more real. We really believe that the automotive industry needs to build this because of the automatic parts and pieces that we have, and the self-diagnostic ability of this specific unit. It almost is like a car. And we're not actually taking a shipping container, cutting it apart and reusing it. We're building something new. We're just using that module size for transportation. We don't want to invent how it's transported. So that's kind of where we're at. I think we're thinking we might be successful, but it's still, a ways to go. We still have to work out a solid IP agreement with the university too on the project, which is something you're familiar with.
I see. Great. Okay, so any question from audience?
I actually have a question.
Yes, Aurora.
Hi, David. I was curious about the supplemental building systems for the project and their integration into the modules. Do you see them as they collapse and they're transporting something that is just folded in? Like I noticed in the renderings, there's some really beautiful lighting sort of tucked behind some of the beds, and there's some coves. Is that part of the built-in modules? And is it also part of the virus or bacterial mitigation during a pandemic? Will that be any sort of the new research that we see coming out of virus deactivating light sources, et cetera?
Well, I think maybe Peter can answer the research aspect, and I can sort of answer, our concept really was that we needed to make each building individual self-sufficient. That's the first thing we did. We took it even further. We want each room to be as self-sufficient as possible. So each individual pod has its own mechanical system, all of its own plumbing and things. So our goal really was that we're only going vertically through these units to connect things. So the reason why, if you were to take a look at staff housing, we're actually stacking everything on top of each other in a very repetitive form, so that all these things can come down in a repetitive way and traverse over into the base and then up into that module where we have the emergency generator and all the storage tanks and everything to actually make these things work. So that's sort of how we looked at it technically as far as systems were concerned. As far as lighting, everything's integrated. Everything is, we want these to come fully furnished. So we're hoping the furniture, if it's loose furniture, that it clips into the wall. So somebody just goes into the room and pulls it off of the wall and they're ready to go. Everything about this project is speed. We're paying a lot of money for speed. And that's everything that we looked at, and every question we asked is, what is the fastest way to put this thing together and to implement it? Remember, it was only a 7-week study. We couldn't solve all of our issues. Peter, you have anything to add?
I mean, I would just add too that in the course of this work, plus a lot of the other research that we've been doing with our other clients, which in a lot of cases it's office workers and people operating commercial buildings. You know, we've had a lot of conversations with our engineering partners, many of the same ones that were involved in this project. You know, medical facilities have a level of air circulation and air handling that is certainly the best among any type of, you know, certainly better than a lot of commercial buildings. But obviously you're also learning about things like ultraviolet light and what those can be used to disinfect, you know, certain parts of the air while certainly balancing safety, everything from ionization technology, and even down to the materiality. So like, for example, copper, which is a material that, you know, doesn't, that certain kinds of germs don't grow on it or don't settle on as easily. So things like that, I think when we get into proof of concept and begin to, you know, design and prototype specific modules, you know, I think we can play with some of those features. But I think this whole project has been a learning experience in terms of what's out there and what, you know, how you can bring it into a mobile facility like this. I did just want to add, I was looking at the text and there was a question that was asked earlier. I just wanted to make sure that it got answered. Can the shutters that divide the units be used as part of the furniture during the setup?
Can the shutters be used as furniture? No.
Can the shutters that
Yeah, I mean, the shutters divide the unit to have two functions. One is when they're an outside wall, they're a fire shutter used to protect the building based on its distance from existing buildings and city streets. The other thing is for transportation, to protect the interior during transportation. Those are the two functions that we had for the shutter. None others that I'm aware of.
Okay, great. So actually, I have one question for an audience. Actually, I can see the Timo live. So he was a student member. So actually, when I was contacted by the David and Peter regarding this project, I didn't want to give up the opportunity because I believe this one is really almost a unique one that our student can be involved, so that they can learn a lot from the really, really fresh blood, so like a practical project. So yeah, Timo, so if you don't mind, so can you share any of your witness or any of your ideas based on your experience during the project?
We have Andrew and Bobby, I see, and we have
Right.
a lot of people from the team.
Right.
Yeah, I can share. I think during the whole project, before the project, we were kind of lack of the information of the COVID-19, how we can actually protect, what's the procedure. But throughout the whole project, when we facing the real issue and when we're doing the construction, we evolve more and more understanding related to COVID-19, and not only help us to understand the importance, how we protecting people from COVID-19, but also educates us as an architect and give us certain responsibility we have to do for the people. So I'm really glad I learned a lot.
Okay.
It was also
any other witness? Yes, Andrew, please.
Sorry, it was also kind of unlike any other architecture work I've done, both in school and in the work environment, just because of the constraints that we were working within, the fast deployment that we were looking for, and this compact kind of self-sufficient design for each module. It made it a lot different than designing just a building. We were designing, like David said, basically a working car within that also functioned as architecture. So not only were we learning about, the normal healthcare design constraints of, air pressure, contamination, sanitization, we're also doing that within the constraints of designing a fully functional car essentially, or, you know, like RV unit that can then be stacked and work structurally as well. So there's a lot to be learned there. You know, I think that within the time frame we were given, everyone on the project did a really amazing job, and I'm really looking forward to see if it can be developed further.
Yeah, I can add something to that. I think I like what Andrew and Bobby had to say about the different learning experiences. I totally share the same thoughts as what Andrew had to say about it being a totally like different experience from the things we learn from academia or the typical things we learn in an architectural internship, because we were given a number of responsibilities that were very integral to the development of the project. And, you know, we really appreciated that. On top of that, like I really learned to grasp the different phases as to how the project was being developed. Not only did David highlight just, you know, getting a modular healthcare type facility getting built, but also looking into the different introspective aspects of it, including transportation, distribution, or even, you know, extracting the units from the actual site. So it was definitely a lot of insight that not only David brought, but also like each individual team member brought into the table. So it was definitely like eye-opening experiences. And you know, I definitely feel like, you know, stuff like this should happen in the school as well, where, you know, students get a chance to not only express themselves, but learn a lot from professionals such as David and Peter.
Okay, great. So any other comment from the previous participant? Okay, great. Okay, so thank you very much. So yeah, unfortunately, we didn't have some large audience today, but maybe because of some conflict with some student classes. So as I mentioned earlier, so since the presentation record will be posted to the research website of the school, so we may have some multiple follow-up question from the student or faculty group. So David, Peter, yeah, please allow us to contact you with some questions from some school member. So, and also, yes, thank you very much for your time again. So I personally look for the remaining phase of the research to be completed successfully, and also hope to stay with us for our future collaboration. Yeah.
Sure. Thank you so much for the time. We appreciate it.
Okay, thank you very much.
Great.
Bye.